Hi everyone, in this video we're going to go over Leetcode 3-sum question. Major tech companies like Google, Facebook, Microsoft are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Given an array nums of n integers, we need n integers. Are there elements a, b, c in nums such that a plus b plus c is equal to 0. Find all unique triplets in the array which gives the sum of 0. And there is a note here. The solution set must not contain duplicate triplets. So what the question is saying is basically we are looking for three numbers and they're going to add up to 0. A plus b plus c should be 0 and these numbers should be in this nums array. So how are we going to solve this question? We are given an array of nums and we need to return list of integers, and we are returning 0, 1 and -1. That's the first one. -1, -1, 2, they all add up to 0. So the solution is these two here in this case. The solution set must not contain duplicate triplets. This is what we need to pay attention here. Let's get on the whiteboard and let me try to explain how it works. If you watch 2-sum-1 and 2-sum-2 videos, we solve very similar question using low and high pointers. But this time we need to solve for 3-sum. So how do we do that? In this case, we go through with a for loop and keep the pointer I here inside the for loop. Our I iterator stops here. Then for the rest of the array, we put low and high pointers, make them walk towards each other and try to find the sum. So I plus low plus high should be 0. So that's what we are looking for. So our sum is nums of low plus nums of high should be equal to sum. Sum is basically I. I plus low plus high, minus I. Our sum is minus I. Minus nums of I, Because sum should be minus nums of I. Nums of I plus sum, nums of I is this, plus sum of low and high should give me 0. So sum is minus nums of I. So the very first thing we do is we sort the array. I will explain why we sort the array in a minute. Then we need to do a 3-step check. The very first check is if I is greater than 0, in this case here, or nums of I is not equal to nums of I minus 1. This is the reason why we are sorting the array. We need to be able to check nums of I and nums of I minus 1. Because what we are doing is we will make these two pointers walk towards each other. If we put nums of I and for example, think about these two numbers, minus 2. I do the 3-sum for minus 2, for example. In the next iteration, I will do the same again for this. So I shouldn't do that. That's why I need to check if nums of I is not equal to nums of I plus 1. If it is, then we continue. So we don't check the same numbers over and over again. And I is greater than 0, so we can check I minus 1. But we cover this case. We also need to cover I is 0 case as well, because we covered I plus I greater than 0. I is this number, by the way. We covered I greater than 0. Now we need to check I is 0 as well. So we have an or. I either 0 I or I is greater than 0, and nums of I is not equal to nums of I minus 1. So we need to check these two in the for loop. For our for loop iterator, if we don't meet them, then we continue. We're not checking the same things over and over again. We don't want to check nums of I and nums of I minus 1 over and over again. So we check this one. We don't want to check same again, because we will put the iterator here. Then low and high work for the same numbers again. Then it's not what we are looking for. That will give us duplicate sums. So that's not what we want. So I hope this makes sense. Let's continue to the second step. In the second step, we check low plus high. A low iterator and a high iterator. So we're looking for, in this case, I is minus 4. Let's write here. I is nums of I, actually. I, the for loop iterator, is minus 4. So the number we are looking for is, in this case, 4. That will give me the number I'm looking for. That will be 4. So low plus high should give me 4 in this case. So what I do is check minus 4 plus low plus high. Okay, that will give me 6. Minus 4, minus 2, 6 is a 3 sum for me. That gives me 6. So in this case, this will return what I'm looking for. So I found the number. High and low is equal to sum. What am I going to do? Again, the reason we sorted the array in the beginning is we don't want to go over the same numbers over and over again. So this time we check if low plus 1 is equal to low. So we are not checking the same minus 2 numbers over and over again, and we come to the 0. And we are not checking and we are not checking 6 over and over again, so we come to 4. Then we check again. What we are looking for is minus 4, and we are looking for 4. 0 plus 4, and that gives me our low pointer is 0, 0, and our high pointer is 4. Minus 4, 0, 4, that will give me again 0. So boom, we do the second one. Okay, we found low plus high is equal to 0. What do? We check if nums of I is equal to nums of low is equal to nums of low plus 1. Nums of high is equal to nums of high minus 1. So nums of high minus 1 in this case is another 4. So boom, we increment it and we come to 3. Okay, so what we got now? 0. What we are looking for is 4. So nums of low plus nums of high is less than sum. Then what are we doing? We are looking for a higher number. If nums of I low plus nums of high greater than sum, we are looking for a number smaller. So our sum is 4. We are looking for a number that's higher. Okay, so we increment low, high stays here, low, and 3 plus 5, again this is higher. So we increment high, we decrement high here. Okay, boom, we found another one. This is low plus high is 4. And that would give me -4 plus 4 is equal to 0. So this will give me, sorry, I guess we did this, didn't we? Yeah, we did this, and we did this now. I didn't mark it, that's why, I guess. And finally, we increment the low and high counter, and this is done for this I index. So what are we going to do now? Check next I index. And put the low pointer and high pointers. Okay, so here what we do is, we need to check I is greater than 0, and nums of I is not equal to nums of I plus 1. So nums of I and nums of I plus 1 are different. So we keep the I here, we keep low and high pointers, and start making walk towards each other for this one. So this is, we will do the same process again for this one and find the next numbers. So this is pretty much how we do this 3-step check. What you need to pay attention is, I can be 0 or I can be greater than 0, but in that case, nums of I should be nums of I minus 1. You may question this, why are they here? The reason is, we check nums of I and nums of I minus 1, but to be able to check this, it should be greater than I should be greater than 0. If we cover this case, we need to cover one more case, and that's I is equal to 0. That's the if statement for loop. I'm breaking down the solution into smaller steps so you could understand. For the second one, low plus high, nums of low, nums of high, we're checking. This if you watch 2 step 1 and 2 step 2 videos, this will make more sense to you. So then we make low and high pointer walk towards each other until we find a sum. So let's see this in the code and try to understand. Oops. Okay, the very first thing is, this gives us extra O n log n complexity, but this is what we need to do. We need to sort the array first to be able to check nums of I minus 1, nums of I, or nums of low plus 1 to nums of low. We need to sort the array first. Then we create a list of integer list here. Then we go through the for loop. Just pay attention, nums of length minus 1, because we are checking 2 numbers here. I is equal to 0, and I is greater than 0, and nums of I is not equal to nums of I plus 1. So this is what I explained. In that case, we started our low pointer from I plus 1 and high pointer in the very last number. And our sum, the target number we're looking for, is minus nums of I. And make the low and high walk towards each other. When we find the number we are looking for, okay, we found it. Now we can add it to the array list. So we add it as list in nums of I, nums of low, and nums of high. 3 numbers, that's added to the list. Then what we're looking for, again, we need to check these numbers, are they equal? Because we don't want to do the same 3 sums again and again. So if low, we are within the boundaries, check nums of low is equal to nums of low plus 1, then increment low. Then in the next one, in another while loop, we do this 2 separate while loops inside the main while loop, and decrement high, and continue incrementing and decrementing low and high as normal. Then if we are nums low plus 1 high is less than sum, increment low. Otherwise, decrement high and make the pointers walk towards each other. and this will return us 3 sum, and finally we return the result. Let's submit and see. Okay, this worked for this one. I hope this makes sense to you guys. I really recommend you watch 2-sum-1 and 2-sum-2 videos to understand this better, and then come back to this, and if that doesn't make sense, just watch one more time. I'm sure it will make sense. I'll try to break it down to smaller steps as much as possible. So I hope this was helpful to you, and I will have more videos coming up. So if you subscribe to my channel, we can meet again in the near future. Thanks for watching. Goodbye.